HAZLOC RMC, rigid metal conduit. In this presentation, we're going to be looking at threading rigid metal conduit, planning rigid metal conduit, assembling rigid metal conduit, and finally, running threads. What are they? There are two different thread types that exist for rigid metal conduit and the equipment it threads into. There are straight threads and tapered threads. Tapered threads are probably less common in the electrical industry. Often, rigid metal conduit will require an electrician to cut and thread the ends. This is accomplished, obviously, with a pipe threader. And there are three different types. You have manual, handheld that are powered, which are fairly new, and then the standard tripod stationary powered threading machine. So a manual looks like this. You hand crank it. It's got a ratcheting handle on it. This is a handheld powered pipe threader. These are newer and have not been out in industry nearly as long. And finally, one that most people will have encountered at some point is the same equipment that would be used by a natural gas pipe installer or something for propane, and that's a tripod. Now, a tripod chain vise is most often used to prevent the conduit from spinning when we're assembling fittings or using handheld threaders. It's also used for support when threading longer sections of rigid metal conduit with a stationary type powered threader. Due to the threaded connections, rigid metal conduit requires a specific order of assembly. In addition, all threaded connections must be made wrench tight. This ensures that any internal explosion is contained within the conduit and electrical bonding is maintained throughout the system. So here we have an example of a threaded rigid metal coupling and a pre-made threaded rigid metal conduit 90 sweep. Also, what differs electrical installations from gas installations is that electrical does not use silicone tape or pipe dope. Let's take a look at a basic installation. We want rigid metal conduit to connect this junction box at the bottom with a 2-inch offset up 90 degrees and a 4-inch offset into the larger explosion-proof cabinet. We need to then measure and calculate the length. Now, keep in mind, this will be a little bit different. The measured distance plus the gain minus the offset shrinkage will give us the total distance of the conduit. And this is important because we're going to have challenges if we don't follow an accurate method or order of installation when it comes to threading the pipe. So for those of you that are unaware, conduit shrink is the distance that we lose when we put an offset or two bends into a conduit, whereas conduit gain is the amount of distance that we increase when we bend a conduit with one bend. So shrink and gain are two different values. In this situation, A plus B is greater than 10 feet. Now, there's all sorts of different tables that can be used to calculate conduit offset and conduit gain, and it really is dependent on what you're most familiar with. And there, of course, is apps available as well. Now, why are we going through this entire procedure? It seems a little bit over the top. Well, the reason is we're going to measure and calculate the length, and then we need to cut the conduit to length. Now, that's a little bit different than EMT. We need to get the entire length and then cut rigid metal conduit. We're going to cut it with a pipe cutter on the pipe threading machine. And then we're going to ream the inside of the conduit to get rid of any sharp, jagged edges. After we've done this, remember, we've now threaded the pipe and it's a straight pipe. If we have a pipe with a 90 in it, how are you going to thread it on this machine? Now we go about bending the conduit into its appropriate length or appropriate dimensions based on what we had calculated. Now we've just created one continuous length of conduit, but remember, one of these boxes will need to be removed from the wall and threaded or twisted onto the conduit. Larger enclosures could pose a bit of a problem with this because everything is threaded. Everything needs to twist on. In these scenarios, it's easier to assemble the item by cutting it and assembling with something called a rigid metal conduit union fitting. Explosion-proof RMC union fittings allow for 2 RMC conduits to be connected without twisting either conduit. There are 3 different parts to it, and it's fairly straightforward. We take 2 parts and we thread them onto opposing pieces of conduit, and then there is a collar that hangs out back here. Thread this one on, thread that one on, then we butt them up together and tighten the collar. Once it's tightened with a wrench, this is completely tight and we can contain an internal explosion as well as bonding has been provided for. The practice of running threads is not permitted. A conduit which has been threaded the length of a coupling would allow, in theory, an electrician to connect 2 rigid metal conduits without twisting either conduit. Running thread installations are forbidden because there is no ability to tighten the junction. This sacrifices both the explosion strength and the electrical bonding. On the right-hand side, we can see that one conduit has been threaded far longer than the other. And that means that the coupling can go all the way up onto the conduit. We then bring the other conduit over, connect them, and then we can just twist the coupling in place. And now, when we just look at it visually, it looks to be a properly installed coupling. However, the thing is loose. It cannot be tightened. And because of that, this practice is not permitted.